In this video, I'm going to explain you to write a program to compare two strings declared in the memory locations using string instruction. How to do this? So as usual, start a new program, start an empty workspace. I'm using MU8086 for this purpose. As usual, I will write each and every steps in front of you in this video. So try to see this video and parallelly try to execute the program yourself, right? So I'll just write dot model small and I will use dot stack. I will give some 20. Okay, so then dot data, right? So first I will try to use two strings. String 1 will be, okay, I will write bits, okay, then string 2 db, okay. I will try to make both the strings same. Then I will try to have two messages. One message is to display strings are same, okay. Another message to display strings are not same, okay. So I will write same strings. Then always whenever you try to display a string, you end it with a dollar sign. That means that is end of string. Always, since you are actually mentioning the memory location of this string, you should also mention the end of string. Otherwise it will print all the junk values which is available even after the last character of the string. That's why always give a dollar sign there, okay. Message 2, so I have to print message 2 when the strings are not the same. Hope all of you understood this, why I have done this, right? Okay, so now I will start writing the code for this. As usual, start colon. Now as I told you, you should, because you have dot data here, something is stored in the data segment, you should load the segment address to data segment register of the microprocessor. That's why what we do, move AX comma at data. After that you put it in the DS register comma AX. I will also put this in the ES register because we are going to use compare S string instruction, compare SB string instruction. Because of that, you should also put it into ES register, right? Okay, so what else next? Let us just put, okay, the count into CX register because it has to compare 4 times. That's why I'm going to put this into CX register. So why I'm putting this? Because I have only 1, 2, 3, 4 characters. I'm going to put it in the CX register. Okay. Now what is required? First you have to put the address of string 1 and string 2 into SI and DI respectively. So how we do that? Load effective address SI comma string 1. Okay. Then load effective address di comma string 2, right? Okay, so then I have to clear my direction flag. So direction flag is cleared using this. Okay, so direction flag is cleared using this. Okay, now next what you do, you just use compare SB, and this compare SB has to be repeated, okay, whenever it finds the proper match, whenever both the characters of the strings are same, right? What this does, compare SB does, it will compare the string byte in the memory pointed by SI and DI, and automatically, because of clearing the direction flag, it will increment your SI DI register by 1. and same time it will repeat on equal compare SB. That means this compare SB will repeatedly executed whenever the 0 flag is equal to 1. Okay, then only it is repeating, otherwise it will come out. Okay, now you see. So what you do after you come out, right? So once you come out, I told you that if you want to check whether the string is same or not, the count in the CX register can be a checkpoint, right? See, if it is the same string, if both the strings are same, I said string 1 is also bits, string 2 also bits. So what will happen? It will complete its entire repetition journey. Yes or no? The compare SB will be repeatedly executed 4 times and your CX will become 0, and then it will come out of this loop. It will come out of this compare SB, right? So if the both the strings are same, when it comes out of this compare SB, your CX register will be 0. Suppose if the strings are not same, assume that instead of I you have BK here. The strings are not same here. So what happens? See, it will repeat only if it is equal. If it is not equal, it will come out. And during that time, you just check the CX register value is not 0. Okay, it is having some non-zero values. So you can use that to check whether strings are same or not. Right? So how do you check it? So I will just use a statement compare CX comma 0 0. Okay, compare CX comma 0 0. Now if CX is 0, okay, that means the strings are same, right? Strings are same, right? So how it is same? Because it will check all the characters, okay, and definitely it is checking how many times? 4 times. That means CX value becomes 0 now because it has checked all the characters, okay, and it did not find anything not equal. Everything is equal and CX becomes 0. So now compare CX 0. So jump on 0. So what I have to do? I will write jump on 0 down 1. Okay, jump on 0 down 1. See, suppose if CX is 0, so can you tell me what it should do? It should display, okay, strings are same, right? It should display strings are same, right? So how do you display a string? Okay, you will use DOS interrupt to display a string. Okay, so for that what you do? Load effective address dx comma, which is that string you have declared for same string to display same string, that is message 1, right? So what I will do, I will put message 1 here. Okay, then as usual I will just move, okay, AH register with the value 09. Okay, fine. Then I will just call interrupt 21H. So then what it should do? It should exit, right? It should exit. So for the exit also I will use DOS interrupt. What I will do? I'll just put move, okay, AH comma 4C. Okay, I'll put 4C. Understood this? I'll put 4CH. 4CH means hexadecimal. Okay, 4CH. Have you understood this? Okay. Then I will call interrupt 21H. This is the exit. After that, it should exit. Okay. So it should print message that the strings are same. Then it should exit. Suppose if it is not 0, if the CX is not 0, CX not indicate. See, if this condition is not satisfied, that means CX is not 0, right? So it will come to the next. It will come to the next instruction to be executed. Okay. So now what you do? In this case, you have to display message not the same, right? You have to display message 2. In this case, you have to display the message 2. So how do you display message 2? Same thing. You just use same program here. See, same program here, same program, and copy paste here. Okay, same program, but here instead of message 1, it will be message 2. And after that, you should exit, right? You should exit, right? See, if you don't exit from here, it will print the message 1, right? It will also print it's the same. That should not be printed. So that's why what you do, you use jump instruction, jump down 2. Okay, down 1 is here, jump down 2. Where down 2 should come? Down 2 should come here, right? So down 2 will come here, down 2, right? So now this program should work for both the cases, whether strings are same or not same, right? Have understood this? Okay. So now you can write here code ends, end start, code ends, ends, and end start. You can write both. You can write here. Have understood this? Okay. See here. This is what the program, the simple program which I have explained you now. Right. Let us save this program now. Okay. You can save whichever destination you want to. I will store it in my microprocessor folder. Okay, I'll store it in microprocessor folder, assembly program. Okay, so I will write it as jag compare yes. Okay, I'll save it as jag compare yes.asm. It is saved there. Okay, now compile it. While compilation, if there is any error message, it will show you error message here. It will show you the error message here in this place. Okay. Otherwise, it will directly create a exe file. You can also create a exe file in the same name as I told you, and then save it in the same folder. Now, don't run it. Try to go for the step-by-step execution so that you can see what is really happening in the program. Right? Now, close it. So, what I will do, I will try to emulate. I will go step by step. I want to see what is really happening. Try to emulate this. So when you do emulation, all this will open. See, right? Okay. Now let us go single step. Let us go by single step. Okay. See, now your cursor is here. Yellow is the cursor, right? Single step. This is executed. See, it is loaded to AX. AX is loaded with the data segment. Which data segment it is stored? Your messages are stored. It is stored in 0712. The segment address is 0712. Right? Okay. Now next single step, you also have to load same thing in ES, right? Because you are using string instruction. That's why you are also going to save it in a ES register. See, your ES register is also loaded with this. See. Now next, SI will have a string 1, DI will have a string 2. Clear the direction flag. Now see here, both the strings are same. It will execute compare SB 4 times. See, first time, okay, second time, third time, fourth time, okay. See, it is executing until CX becomes 0. See, CX becomes 0 here. See how it is executing. See, so moment CX becomes 0, see here, it will compare content of CX with 0, 0. Now, because both the strings are same, bits and weights, CX becomes 0 because it compared it 4 times within the loop because we have given repeat equal. Okay. Now what happens is jump on 0 down. Right. Now result is 0, right? Result is 0 now. That means it should satisfy this, right? Jump on 0 down means, now tell me whether it should go to down 1 or not to go down 1. It should go to down 1. Right? So now see it is going to down 1. Now load the message 1 in DX. Okay. Put 09 into H register. Then call the interrupt. Now it should say strings are same. Console will open. Okay. Now see, can you see console? It is printing same string. It is printing same string. Right? So this is the console. This is the console. Okay. So it is printing same string. It's printing the output same string. Now continue. Okay. Now continue. It will exit. See, it has come to move H, force H. You can see here. That is the next. After that, it should exit. Right? It should exit. See, after that, it will exit. See, it will exit. Program has return control. Okay. Have understood this now? Okay. Now let us see that. I will close this console. Okay. You can keep it on your screen. Doesn't matter. If you want to do the clear screen, you can do the clear screen. Okay. This is the console. Now I will try to reload this program. Okay. So before that, what I will do, I will try to change this to BKTS. Now it is, those strings are not same, right? Your program should display not same. Okay. Now I will try to emulate it again. Okay. Now execute with a single step. See, now it will come out. See, can you see here? CX will not be 0 and it will come out. See here. It will come out. See, it has come out. Have you seen this here? It has come out. When CX0 it has come out. Now it will print message 2. It will print message 2. See here. It will print message 2. See, not the same. It is printing not the same. Have you understood this now? Okay, now continue. It will go to jump down, exit. Now it is exiting. See here. Have you understood this? So now I will try to change the strings again. I will just put some other string. I will put Pilani and I will make both Pilani. Okay. I will try to compile again. If you want to do compilation, it's better you do compile it again. Save, overwrite, not a problem. Now if you want to run, you can run it. See, it should show, see, same strings. Can you see here? It should show same strings because your strings are same. The strings are the same. I will change one character here. I will make it K. Okay. Now if you want to compile, you can compile or you can emulate directly. Okay. See here. Now if you want to go for single step, you can do single step, or if you want to run, you can run it. Right. So it is showing same string. Why? Because the count is 1, 2, 3, 4, 5, 6, right? Right. So I have to change the count now because earlier I have written for 4. Now I have to take it for 6. I have understood this. Okay. I have to take it for 6. Right. Because CX is now changed. That's why 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That's why you put this in the 6. Now you try to emulate it. Want to compile it again, compile it. Okay, save. Run. Now you see not the same. See, not the same. Have you understood this? You can also execute this in Turbo Assembler. Right? You can also execute this in Turbo Assembler. Okay, in TASM you can type the same thing. Okay, so I will tell you how to do this in Turbo Assembler. I will open Turbo Assembler from here. Okay, I will close this. I'll open Turbo Assembler from here. Right, the program you can type in the same program. Okay, so before that, what I will do, I will try to paste the program which I have in my folder. So what I will do, I will just try to paste the same program, whatever I have. So I have this program here, the same program which I have. I'll copy and paste it in TASM folder. See, I have a TASM folder here, and I will paste it in this TASM folder. Okay, so jack cmps.asm. So what I will do now, I will just go to Turbo Assembler. Okay, so same program has come here. Can you see here? Same program has come, right? Okay, so now what I do? TASM jag CMPS dot ASM, right? Okay, it's having one warning message, doesn't matter. Okay, warning is not a problem. It says unmatched NS, okay, code NS, okay, doesn't matter. So now what we do? T-link, right? T-link jag CMPS dot obj, right? Now do I need to go for turbo debugger? Not required, right? I can directly execute the exe file jag cmps dot exe. That's all. Not the same, right? Now I will go to the program. Again I will change. I will just go to the program. I will make it same. I will make this as same. Okay. Now it should display same, right? Same. Earlier it displayed not the same. So once again you have to save this program. Okay, exit. Once again you have to do TASM. You can use up arrow. Once again you do TASM. Once again you do T-link. Once again execute the exe file. You should give same strings. Can you see it is showing same string in the bottom? Right? Okay. So you have understood how to use this string instruction. Compare, yes, to compare two strings. Okay. So hope you have understood this program. So whatever program you are practicing, you try to execute that program either through this emulator, or you can just execute it through TASM, right? Okay. So you can, if you want to use recent file, you use the recent file, open it, see, open it. Okay. If it is already compiled, directly do the emulation, emulate it. See, this is something user friendly. Can you see here that I just have to do single step execution here? See, if you want to see the memory location, right? See, if you want to see memory location, string 1, string 2, message 1, message 2, all these are memory locations, right? Okay, how your this Pilani, this character is stored? Okay, just go to view memory, right? So now you update the data segment. Now it is showing 0715, but it is 0712, right? 0712. Okay, I will just use this 0712 update. Can you see that how your data is stored? See, in the offset address 000002 somewhere Pilani. This is PILANI. This is PILANI. This is string 1. This is string 2. See, it is equivalent ASCII. The character is also shown here, right? So this is for 50, 49, 4C, 41, 4E. These are all the ASCII value, hexadecimal ASCII value corresponding to Pilani. And also similarly, you have something else. I have changed the data, right? I have understood this. Okay. So you can see that what is really stored in the see, and also message 1 and message 2. See, message 1 and message 2 is also stored accordingly. Can you see here? After that, immediately these are stored. Can you see here? Right? You can see here. See, all this you need to understand how the data is stored in the memory. See, now where it is stored? It is stored in the data segment 0712 and offset address 000. So it is taking offset address as 0000 here. Have you understood this? Okay. So this is the way you have to execute the program and also practice the program. I'm sure definitely this programming will become very easy for you and you will start liking the programming. Otherwise, I'm sure you will not be able to learn programming very well. Practice is very important for programming. Okay, so hope you can understand from this video. So with the comments if at all you have any doubts, anything on this video, okay, so that we can make more videos for your practice.